Alright, Mastering SolidWorks, Chapter 13, Building Efficient Assemblies. This chapter introduces you techniques you can use to manage performance issues as well as general use issues, efficiency, browseworthiness, searchability, and assemblies. In this chapter, we will learn to set part elements of an assembly, increase performance by speed packs, organizing assembly by using sub-assemblies, group parts, and mates by using folders, show names and descriptions with tree display options, and employ helpful assembly tools. Understanding the purpose of assembly in the physical world, assembly exists in several reasons: separating materials, allowing relative motion, reducing material, allowing different manufacturing techniques, allowing for disassembly or repair, independent reasons for streaming the physical world, requirements. CAD assembly may have some unique reasons for existing, depicting an assembly process such as order of operation, specify dimensional assembly, relation to the tolerance, establish clearance limits of the motion, visualizing motion, spiritual relation between parts, designing parts in context, creating part lists for assembly, bill of material or BOM, creating parts list purchases, automating data through product data management or PDM, stage renderings, creating data from downstream applications such as animation and motion analysis. You can probably come up with a number of additional reasons making CAD assemblies. In fact, almost many of the reasons for the making assembly that are people to making those assemblies. If you're trying to drive a product with single top-level assembly, you might run into situations where various functions of assembly starting conflicting with one another. For example, you might have the assembly where parts flex. It's difficult or impossible to make flex parts where efficient SolidWorks for the dynamic assembly motion. Another situation might be the in-context relation with the parent-child components will move relative to one another. You may need an assembly rendering. An assembly must have the multiple instance in-context components which can be tricky to manage. You can get the big picture. You can always do everything in a single assembly. You can certainly have multiple assemblies files for a single product. In fact, in some cases, this may be necessary. Rendering is probably one of the most common reasons to create new assemblies. Conflicts between external references, motion, any other common reason to create new assembly to document. Identifying types of assembly. The average SolidWorks user thinks assembly is a collection of parts put together with the mates, the position parts, and may also allow motion. In this kind of assembly, you might use patterns, configuration, context techniques, and so on. The goal of assembly is probably to simulate reality in the way a product looks or moves. Driving assembly with the base part and mates, bottom up with the mates. Considering orthodox SolidWorks assembly usage is the way of SolidWorks training materials, designing, creating assemblies. Insert with a part of sub-assembly at the origin where he becomes fixed in place, automatically starting mating part sub-assembly to the base component and add on from there. It's difficult to criticize the assembly modeling method that may be used for so long. So many people have high failure rate of mates attached to the edge of face speaks for itself. SolidWorks has tried to solve the problem many releases of the software, but failure rate hasn't changed much of it at all. If at all, you may find the software even tries to hide certain types of mate errors to make it easier to ignore. If you're reading Chapter 12, Editing, Evaluating, and Troubleshooting, you know that you must have common methods of part modeling, also easiest, most prone, error prone. I ask you, consider the same true with the assembly modeling. To make truly robust assembly, a little more forethought is required. Chapter 12, Using Reference Geometry to Build the Bones of the Part because of the more stable approach. Here will assembly, I recommend the same. The bottom line of this method, mating the base parts, is the unreliable through change of methods presented in this book. The most common yet most reliable method. This is not a fault of the software, but the method. Faulty method is popular because it's the easiest and requires least planning. Example where you might use kind of assembly is a robotic arm. Figure 13.1 shows an assembly created with the bottom-up techniques, parts made individually assembled with face-to-face mates. So here is a mechanical part using mates, location, enabling motion. Alright, but if you were to create a scale model of a car shown in Figure 13.2 with a model with independently designing each component, especially something like a body panels, then mating them together would make much sense. Method of the other types of assembly shown later in this chapter will help you with this type of design. Figure 13 shows considering how you would design parts of a scale model car. Using bottom-up mates method to design panels for a car so that they fit together well and look smooth next to one another would be difficult and impossible. Driving an assembly with sketches and planes, bottom up with a skeleton. One way to avoid potential pitfalls is mating base part with a replace the changeable faces, edges, items that are more stable, shareable. Hierarchy listed items that most of the least stable looks like assembly part origin, assembly or part standard planes, reference geometry plane, access point, reference geometry, inserted parts using insert part command, sketch line, midpoint, sketch endpoint, surface model, solid model, faces, edges, vertex, intent, text, items, reference geometry and faces and edges. Easier way to remember without memorizing the list is that more parent something has, the less reliable it is as a reference. This becomes more applicable if the external references are involved, so the inserted part of the in-context situation, edges created with the fillets or chamfers are lower than less stable reference of the other edges. There's no clear answer for this question. If the reference is stable enough, it's entirely possible that you may completely successfully use the context in-context edges for all your model references. In order for this to happen, you have the plane model very well. Avoid any big topological changes. Change the number of function faces to the model. When you're building a part with a selecting reference from the near to the top of the previous list can be challenging, especially with the faces and edges are easy to use. You need to evaluate how editing, reworking your thinking you will generally when you most of the changes review haven't necessarily planned. Now consider the two examples mentioned previously, Assemblies model methaning, robot arm, model car. You can design a robot easily with a sketch layout, but simulating motion over 3D would be difficult if you did not find junction with a sketch. The model car would be still difficult to assemble if you were simply using sketches as reference between parts. It would be difficult to design the body panels so that they fit together smoothly. Model parts in place in context design. In context design is discussed in more detail in Chapter 20, Modeling in Context. But here we'll get some idea of what to expect. Modeling parts context is assembly that contains the other parts and enables you to make the relation between the parts. Those relationships are managed by the assembly. The parts can have the range spatially with respect to one another, and reference to the files must be managed. When you see the same sales demonstration technique using the edges of the other parts from the assembly to make the new parts look very compelling, especially when you make changes with the other part with the new parts updates as well. It's hard to argue what kind of functionality, but the price you pay for the sort of associativity is that you must manage relations between the files, the parent part, child part, and the assembly. Furthermore, within the assembly, the relationship are made between the specific instances of the part. So if you have multiple instances, each must do the same thing, something to remember which pair of parts is the driving pair. Also, model history, which parts do not work the same with the assembly. The relation between the parts that does not have any memory. If you start with the context relation before the parent was complete, then put the fillets over the edge that have the reference for the in-context reference would fail. Take another look at the robotic arm model car example. To use the context method, you can certainly design a robot army, but again, you might run into some problems when getting into the move correctly while maintaining the references. However, the model car gets parts if them in the right place wouldn't be any problem, but because you would model the parts in place. On the other hand, you might be able to get shape to flow smoothly, but it's still doubtful in context modeling. Copy a 3D surface between parts, but in an improved workflow for this type of the work, you must read further in this chapter. Example of the part modeling in context works well as table with legs, as well as fixtures of the sits of the table shown in Figure 13.3. The in context work lines of up to the holes between the parts that are known relative to the movement and between the parts. Individual parts are likely to be used in other assemblies. The ideal situation using the in context techniques is two parts are assembled. Face on face, shape of the context face are the same offset, but the holes are used as fasteners. Main requirement is there is no relative motion between the two parts. Modeling parts as multi-bodies. Another method, you can use the model parts at the start of the model multi-body part. I don't recommend the method creating finish as part of the multi-bodies, but getting some of the major parts assembly started with single parts, then breaking them out with the individual parts for the detail can be a very effective method. Suppose you're modeling a riding lawnmower and you need to create a plastic cowling on the front of the mower. The cowling is made up of multiple pieces because some of them are different colors. Some are transparent. The complex shape of the cowling encompasses the multiple parts. If you were modeling one part, then try to model another part independently, they are shared, and some of the same shape. It would be very difficult and impossible to get the shapes to match acceptably. Figure 13.13 shows the context method the best advantages. One answer for the problem is to create the shape of the single part with the break of the single part into individual bodies, save the bodies external with the original part. When you put these parts back together in an assembly, each part can be placed with the original matches with the assembly at origin. Because all of the parts started with the same part, but they were shaped with the same origin, this part makes the part of it together much simpler. It makes it easier for the motion with the difficulty of the part to have shape of the common and more likely to be fixed with respect to one another. Multi-body modeling has advantages over in context modeling with a reduced external reference, although saving the bodies out of the parts creates the external reference, but also has some drawbacks. If you were to talk all the feature for the individual parts, stack them in a single feature tree with a single part with the problem to be unhappy with the result, making all of the feature for the part within a single part would make the troubleshooting more difficult and the rebuild times dramatically increased. To add this inability to reach part with the do individual revision management, perform simple assembly operation, dynamic motion, exploded views, bill of materials, and following with the multi-body method through the finished part, or becomes very unattractive. Best option using multi-body to create parts for the assembly is to start parts of the multi-body mode. This soon as the inner body reference is no longer needed, transition the body to separate parts. Multi-body modeling, it may not do so well when parts are repeated, but when purchased, completing representing a large percent of the total parts. Although you do have mate-like functionality, placing bodies with a multi-body part is probably not the best use of the FIM method. Figure 3.14 shows the product with a design multi-body, which involves many difficulties because of the reuse parts and hardware. So reusing parts and the strength of the multi-body methods. Revisiting the test each method, you would find that the robot arm was well suited being with a design multi-body with a reassemble the mates. In fact, with a multi-method, it is probably the best method for the type of the work because of the maintains reference between parts and some of the part with some of the mechanism within motion model car, which in shape flows for the between the parts feel awkward, although could be done individual point. Looks like and last method to see helps with the car model inserting master model. You will learn about the master model technique in Chapter 33, employing master model techniques. In a nutshell, master model is a single part where the place of the sketch for the reference geometry surface may be made some solids. When you insert the part with the other parts, you have the reference to the build of the individual part. You have the technique making context work unnecessary, but eliminate some of the danger for the creating of the too many features for the multi-body part. Your assembly parts of the manager and some of the multi-part body method. Then you drop each part of the feature frame within the assembly, aligns the part with the origin, with the assembly origin, because each of the part was built with the same master model. All of the parts share the same origin. Take another look at the robot arm model car example. Robot arm may be a little bit awkward using method, but works the multi-body method, probably the best of the type of design. On the other hand, master model method brings real power of the project, such as the model of the car you design with the entire outside of the car as if the single part. The break into the individual parts, figure 13.5, notice how some of the parts were manufactured as a single part, but can be easily pulled off of the master model sketch of the master model. Can help define breaks between parts and help determine the relative of the motion, for example, with doors. Figure 13.5 shows pulling off of the parts of the master model. Excluding some of the parts method stuff of the amendment mentioned previously, any of the greater of any of the part uniquely assembled should not be used with the library types. If you have part will be used with more than one assembly, you should not have any of the external reference. All the methods of the create with external reference except for the bottom up assembly where the parts are moved and modeled individually and then they are assembled to one another to a skeleton. Any library parts that have the standard hardware, such as the nuts and bolts and washers, so on, should be modeled without reference. You should not create them as a part of multi-body parts. Some of the Solidworks users think eliminating distinctions between assembly and the parts would be a good thing. The point of the view works for the simplest small assembly with the simple parts. Easy to come up with a situation with the tree management tools required for the maintain bodies, both built using philosophy throughout the transgenic even existing software. Creating alternative multi-assemblies. Creating an alternative to multiple assemblies. Recreating and copying assembly with a different use of very efficient. In Chapter 19, controlling assembly configurations and display states. You will learn about another way using assembly configurations. Assembly configurations are a great tool with lots of theoretical benefits, the practical limitations, and most other functions. In Solidworks, you need to create assembly multiple purposes. You find with the assembly configuration meet your needs. I may find with it easier to save the copy with the assembly, knowing the changes for their sake. Running do not diminish the usefulness of the data of something like an exploded view of the managed external in-context reference. Identifying the elements of the assembly and a number of the parts of the design requirements assembly grows. You may need to add some of the following types of the assembly elements: assembly equations, assembly layout technique, assembly reference geometry, plane, axis, point, coordinate system, parts, subassembly, folder parts, folder for mates, assembly features cut there, made in the parts, and assembly component patterns, mirroring components, in context reference, placeholders, smart faster, smart components, virtual components, envelopes, assembly configuration, speed packs, display states, assembly design tables, assembly build materials, hidden suppressed lightweight speed pack, performance techniques, sensors, holes, and sensors. Whole series. You may already be familiar with some of the elements have worked in with the part document showing figure 13.6 in detail throughout this book. Figure 13.6 show the elements of the assembly with the Bible-like assembly. It has all the assembly junk elements of the assembly. Working with assembly equations work like the part of the equations with additional complication for the consideration. For example, the additional feature for the assembly equation is ability to derive the dimension one part from another part, but the syntax is slightly different with the assembly shown in figure 13.7. We've looked at the equations, global variables, through the assembly and the assembly part tree. Solving external references. Note that the arrow symbol for the equation folder is an assembly feature management, but it means the external in context reference. External reference means that the aspect of the one part depending on something outside of the part. This is a file management implication because you maintain with the names of the file, but always recognizing the other file involved in the external relation. In context means one part of the relation to another part in a position determined by an assembly. In this case, the in-context external reference can be solved only with the original part, with the reference part of the assembly, with the relationship was created with the IR all at the same time. Understanding global variables. Global variables all work in assemblies, but also work in assemblies, but they do not work between parts. Local assembly sketches can use these functions. The parts of the use them edited with the context of the assembly. Renaming. Equations update with a new part named regardless of how you rename the parts. Names of the sub-assemblies update when you rename the assembly files. This includes renaming the document you can save with the command using Solidworks Explorer, using Windows or using Windows Explorer. Also include the redirecting assembly with the new part name, as well as renaming the assembly using each of these techniques. If the assembly can find the part and recognize the part as one of its looking for, the equation will work. Some of the methods mentioned previously with the renaming the part of the not recommended Solidworks Explorer and Save As method that can be effective when used properly. References between files, different issues from equation references to local file names. Recommendations. Although assembly equations are certainly a valid way of the control part side of the use of the assembly with the part configuration possible the design table to accomplish something similar. Equation configuration do not mix well with the cover of the two methods with the click with one over the one with the control dimension configuration with the design table recommended over the equation. Caution, you have the unexpected result of the single dimension control of more than one location. For example, if you have the part level equation, assembly level equation, the one equations will automatically say the read only will not be used. Solidworks Explorer. Solidworks Explorer is a simple file management tool that you can use with or without SolidWorks. You can access it through the menu, Edit Tools, SolidWorks Application, Solidworks Explorer. When initially open, it looks like a search function you can use. You can expand with the Window Explorer type window with specifically SolidWorks functionality such as adding text, properties reference when you use the configuration, and more. 13.8. Figure 13.8 shows SolidWorks Explorer helps you manage several aspects of files. You have info, property, reference, configurations, where you use hyperlinks and view. SolidWorks Treehouse. SolidWorks Treehouse enables you to create framework with the product assembly. You the empty part and empty part assembly. The drawing files you give the SolidWorks build with the actual geometry within the file created by the Treehouse lead engineer manager. You would use the Treehouse to set up the structural assembly, complete with the sub-assembly part of the drawings, then plan the work, draw with a complete design. In the Treehouse, you can create, organize assembly structure, create files, SolidWorks document templates, name files, create edit properties, create edit configuration, include existing documents from Windows Explorer. 13.9 shows SolidWorks Treehouse helps you to create the assembly structure, go to the assembly part, sizes, drawing an existing file. You can have the assembly with a different part, assembly, and then a tree house. So it's kind of like a family tree. And that's the tree house. To start without working on a new assembly, put your cursor over the assembly icon and then drag the assembly template into the work area. To put a part in assembly, put your cursor over the part icon, drag the part template over the assembly icon placed earlier. Alright, using assembly layout sketch. Just show the Solidworks assembly feature for layout with the 3D sketch layout with a major function of the assembly, even the detail parts. The word layout refers to a long-standing technique with the 2D sketches assembled to do exactly the same thing. The distinction between the technique and the formal assembly feature is bound to be confused in layout with a feature for the relative and never new and works only in assemblies, but the layout techniques have been used in part as well with the assembly for many years. The simple case of the unfortunate naming of the specific function of the name already used with the general technique. Last, just acknowledge this confusing, move on. When you look at two functionality of the feature, definitely intended that you use in the context tool, although more easily technical with a reference with the control part position through the mating rather than a way to direct control the size and shapes of the part. So when you reference the layout with a capitalized reference refers to the formal feature where the reference to layout sketch refers to technique where the sketch is used with the part with some level of the control geometry or part placement in some way. Layout of the sketch is very useful for laying out the mechanism of the assembly. Even the details of parts of the assembly sketch for the assembly have some of the characteristics as. Alright, 1310 show the sketch control geometry of the frame over the overall bicycle assembly. They do in the part of the environment. In figure 1310 of the assembly layout sketch is indicated with a heavy dash line of the emphasis. When combining with the context technique, the assembly layout sketches can help determine the shapes of the part, location, size, shape, the feature within the parts. You can also use the layout sketch for the assembly components for more robust, depending mates rather than mating the part to part. The sketch shown in figure 1310 is used with both of these techniques. Shape of the frame and the major pivot points are established in 2D sketch. The wheels are also made with the sketch. When using assembly layout sketch for either the in-context part of the building, simple part position, main advantage of it gives a single drive in the sketch that enables you to change the size, shape, of the position of the parts. You can use many layout sketches as you want. You can make them on the different sketch plane, but it enables you to control the parts in all directions. Caution when using layout sketches, assume the relationships are created over that side of the sketch drive of the parts. However, nothing prevents them from using the elements of assembly to the drive of the sketch that you should avoid of this type of conflict called circular reference. Create sketches that change with every rebuild with a series of impact rebuild times using a type of the in-context relationship between items in the assembly. You need to be careful to establish one more driven entities which is not in turn driven by other entities. Take this step further to avoid daisy chains, whereas A drives B and B drives C and so on. A better practice is to A drives both B and C directly. This saves rebuilds and troubleshooting, reduces future problems of lost reference. One drawback of the technique, you give the dimension assembly motion of the move parts. You have to move the sketch or rebuild the part moves on until the sketch is updated. If you need to combine local layout functionality with the dynamic assembly motion, refer to the discussion later in feature 16, working with assembly sketches and layouts. Working with virtual components. Virtual components are part of are saved with the internal to the assembly. You can save them out of the external out to the assembly and can be used in the other assemblies. Also, you can convert external components to the virtual components. Virtual components, with the name suggests that it can be either parts or sub-assemblies. You may consider virtual components certain types of the parts that need to be in the assembly but not require drawing, such as glue, paint, oil, and so on. You can even use virtual components model purchase assembly, sub-assembly with a flex. For example, you can create a hinge. Use the hinge assembly as part of the library. However, they achieve the virtual components, make sure that they won't cause any difficulties downstream file management, data sharing, other requirements. Creating assembly reference geometry. Alright, planes and access frequently created with the assembly with the drive and symmetry with the placement of the parts. You can use the layout sketch for the create with the reference geometry entities. When you create reference geometry within the assembly in a way with aware of the new normal parent and child relationships are still following. The familiar icons reference geometry entities are also used in the assembly tree. Comparing history based on non-history based portion of the assembly tree with the become of the feature for the reference geometry for the history base found in the assembly tree with the least portion of the assembly feature manager for the history base. However, not all of this. For example, the list of the parts and sub-assemblies is not history based in the order it does not matter at all in the software. Sketch reference geometry may appear with a before and after a list of parts of the sub-assembly mates. All remaining even the types of the be found when the assembly feature manager of the history based feature that you can reorder in the tree. However, the civil situation disrupted the process under normal circumstances. Discussions and reference geometry of the top of the assembly. The feature manager was solved. The parts are rebuilt with the required. Then the mates are rebuilt with the ensure the sketch of the reference geometry they are in the correct location. So the parts are mated to them. All the components end up being in the correct side with the right position. Assemble level the reference geometry can be created with the reference component with the geometry and the set of the layout sketch for the created. It depends on the change with the usual order. For example, the planes usually solved before the part location, but between when the planes is dependent on the part location, the plane must be solved after the part. If the part is moved into the plane, you will then begin to create with a dependency loop that says for the plane is solved followed by the part. Then the plane again with the part that has been moved with the mate that goes to the plane must resolve the part. Best practice. If you are a bit confused by all this, don't worry. But you can simply follow this rule: do not mate to anything that comes after the mate assembly feature manager tree. This includes assembly plane sketch of the dependent on the part geometry, well as the feature within such of the cut and context feature of the component of the pattern, instance of the whole series of smart fasteners. This is probably a lot of information absorbed from the new user, but if you remember this rule, you can avoid creating a model with a circular reference. A is dependent on the B, which is dependent on a never-ending loop, which causes the major problem of large assembly rebuild times. Understanding parts and sub-assemblies. Part and sub-assemblies are shown with a familiar icon of the design tree. They reordered with a group of the folders covered in the next section. Edit hierarchy of the parts and sub-assembly with upper level assembly. Primary text of the part assembly helps to organize the data. Information from the relation of the geometry of the single manufacturable item is put into the part. Information from the relief of the relations between the parts is put into an assembly. You may hear some people argue that the parts and assemblies don't have the different file of the types in one part, but they should be handled with both the geometric data of the relation between the items. Or not even the data in a different type of the necessary, because it helps the computer know to calculate with which data. For example, if your computer had to rebuild all the features within every part, as well as mate rebuild times would be suffer greatly. In addition, parts and assembly are different of the bodies within the part. If the bodies within the part of the feature with one big list, remember the segment of the individual list for each of the part of the important of the reason rebuild time of the troubleshooting error of the read the data part features that are in a big list of the other parts of the feature that cannot be organized and separated easily for the other purposes. Organizing mates. Mates remain constant single folder, but you can organize with the reordering mates with the grouping in them into the folder. Each mate is shown with a simple corresponding with the type of the mate, but this mates folder is shown as a pair of paper clips. So you see the paper clip is actually the icon for the mates. Tip: in the previous version, mate folder was broken up with the various mate group with the model with the head of mate with the cause of the history and of the rebuild. Therefore, the mate each of the group of the rebuilt with its folder. This had an effect with confusing a lot of people. The Solidworks combining them all into one with combining all the mates in a single folder always. If you even ignore what you may make when you make a mistake with the mate of the history base of the item in the tree, thereby causing the error of the mate of the group to be created. This is an example of the Solidworks trading. Ease of use for lack of control. Mates are typically shown at the bottom of the assembly features in their own area, but they are organized fully underneath each individual part, so you can see the mates that each part is involved in shown together 13 and 11. Alright, we've now went to mate 13 and show the mates for all the bike assemblies. We have the coincident, symmetric, angle, concentric, bike frame, lever assembly. Symbol look ground next to the mate symbol will help you identify with the mates for the connect with the part of the ground. Another fixed part that prevents the mated part from moving another way with the organizing the mate for the chain with the assembly. The feature menu for the display with the pair of the chain with the work together the only to show the hierarchy feature for the detailed toggle. You have the view teacher for the feature for the mates for the dependency for the toggle. If you choose the hierarchy the mate with the dependency option, you can get the tree where there the mates are shown or under the part and sub of the assembly name shown in figure 1312. Show hierarchy feature detailed toggle is found top level the right mouse button menu. The feature view feature mates and the dependency the toggle is found with the same right mouse button menu under the tree display which shown in figure 1313. Assembly is applying assembly features in manufacturing after the parts assembly secondary machining operations sometimes apply with the ensure that the holes line up properly. Other purposes, for example, the assembly feature for the extrude for the cut revolve the holes feature for the pier only on the part of the assembly level, not in feature for the individual parts. You should not confuse the assembly feature for the contact feature for the contact feature of the creative for the editing the part of the assembly reference between the part of the part. Sketch feature for the definition of the actual part. Assembly feature sales call for the additional assembly complexity. If for the main assembly there feature, you can use another hitch for the assembly rebuild the cycle that formerly would have the creative with another mate group with this even need with the confined feature. This is fine. Make it extra careful not to mate it to or create into context reference to it. If functionality of the Solidworks seems powerful, it probably is, but there's always a price to be paid for the power. The cost usually repeals speed with the more complex troubleshooting if you have problems. Shift the hierarchy, mate dependency of both the dependency parts. Settings, organization, display mates. Now if you went to the assembly tree, we went right mouse button and clicked the assembly. Went to show feature detail and also view mates dependencies. These components, patterns, and mirror components. Component patterns can mirror either part of the subassembly, creating either pattern with a defined assembly with the pattern file with the pattern feature for the creative, and the pattern with the patterns list for the feature for the assembly, feature manages all of the instant of the parts applied and intended. Pattern feature for the design tree with the connive is provided for each for the instant of the chain, but its configuration must wait for the control of that as well with the regular part of the design tree. Because of the optional locally defined patterns are competitively limited to user general, like with the U of the pattern, part of the patterns, drive of the component with the patterns where possible. The component parts are listed bottom of the assembly feature management with a set of the components with the local pattern icon. The component instant of the under local pattern can be controlled in some of the ways, including the assignment, configuration, color, display state of the pattern can also be the dissolve of the leaving the component with the moving of the intelligent pattern that places it. Mirror components are listed under a special mirror component icon after the mates performance. To improve performance, you should pattern of the subassembly and possible to not possible the patterning of the group of the parts of the next to the best option, making multiple patterns one in each of the part with the inefficiency way that accomplish the same thing. Using a speed pack, which shows the assembly with the dash lines, giving it like a little thrashing moment. Alright, speed pack is a derived configuration assembly that keeps only selected solid bodies and faces of the kit and represents for the rest of the assembly. The not selectable display tab. They can use the speed pack with represent the entire assembly with the upper level of the assembly. Speed packs are intended to increase the performance for a large assembly and drawing the figure 13.4 show the speed pack property manager on the left, which acts to the right with the clicking when the active configuration with the selecting add speed pack. Each configuration can have only one speed pack with a certain image of the figure 13.14 show the configuration list of the speed pack and intended under the default configuration in the entire assembly. The right image show the speed pack and serve the into the assembly document consisting of a single phase with the two solid body with the notice of the special icon associated with the speed pack. You can change the part of the assembly from the speed pack in the same way they would change with the configuration and the component properties. Remember that this is the tool increasing the assembly speed, but you must always give them something to increase the speed. The speed pack is similar to lightweight assemblies of the component in that they would display only tab, but the exemption for them. This tool management is that it's actually a functionality you will be dissatisfied with. Speed pack offers for the reason that it is important to understand the ability limitation of the speed pack. Alright, using Ghost. You can use any face of the bodies just like with the include the list of the manually through the quick and included sliders, which automatically select the body and face on based on the size assembly of the mate with the drawing with the dimension of the geometry that isn't selected with the include the Ghost that displays, but you can not select it. When you move the cursor in the air of the Ghost, geometry for the Ghost fades away, revolving only selectable geometry. Notice at the bottom of the speed pack. The properties manager then can also choose to remove the Ghost tab, further increase memory saving. The 13.14 show the managing speed packs, modeling garage assembly for the SolidWorks. We're now gone to SolidWorks and have the different sketch loop, last loop, plane, edges shaded, plane with shade. Geometry, exterior body, all views, more, remove ghost, graphic add, rebuild, and then this shows the ghost over here. The speed pack are sharing self-contained data. Speed pack and self-contained, all selected face with the body with the geometry saved inside. Assembly, if you want someone else to visually representation assembly, you can make the speed pack configuration send it. Only one assembly, no parts are required. This is equivalent to being able to put the drawing into the assembly. Using speed packs for the drawings, you can even use the speed pack for the drawings. Just remember the only edge of the creative, the face of the body, but include the list for the dimension of this functional exhibit for the ghost tab, with the type of the build material, inclusion, the number of balloons, ghost data display for the engraved with the drawing with the geometry for the include the list in black. Using subassembly, the primary tool for the organizing assembly is subassembly. Subassembly is just a regular assembly. The component is in another assembly. Best practice, you're not limited to the specific number or level of subassemblies over the different side of the type of assemblies used. You should establish the best practice for your company. For example, you establish a guideline with the suggested assembly 100 parts or fewer. Go no deeper than 3 levels. You can use criteria to determine the subassembly assigned, performance, bill of material, relative motion, prefabricated, off-the-shelf serialization according to assembly time, assembly steps of the process of the drawing. To simplify the pattern, understanding the questions here based with the multiple function SolidWorks assembly model, the assembly, the intent of the problem for the design, visualization for the documentation, for the process of the documentation, when you primarily design with the assembly, even to determine physical tolerance mechanism and many other things. The visualization tool is simple to look, good possible, move the properly, the parts of the design documentation of the tool, how the body model relates to the bill of materials, importance over the order of the sub-assemblies, when you have the sub-assembly, the process of the tool, you need to be able to show the assembly in various intermediate state of the being assembled likely with the configuration, creating sub-assembly with existing parts, creating sub-assembly from the parts that already exist in the assembly. To do this, select with the parts you want to add to the sub-assembly, pressing and holding shift the control key, use the box selection techniques, then selecting the form of the new sub-assembly here with the right mouse button menu with the will be prompted for the assignment of the new and possibly select the template for the new assembly. Caution when you create a new assembly with the existing part of the moving parts in and out of the assembly with the upper level of the assembly. Some things may be lost. For example, the mates are removed. Mates are moved to the upper level of the assembly, and if you have the context relation, they may be removed, and you cannot easily undo the operation creating a sub-assembly. After you've recreated a sub-assembly, you can add and remove components using the drag and drop method. For example, the 1315 show the two different actions with the two different cursors. The one left over the cursor would indicate the parts of the name BB is being moved into the sub-assembly named bike crank. On the right, with the cursor that indicates BB is being reordered after bike crank. To move the part with the sub-assembly, you can simply drag the part into the upper level assembly. So on the left, we have part named BB moving into the bike crank, so we dragged it into the bike crank, and then on the right we took BB and we reordered it in front of after bike crank. So that's the option rename component operate currently off the tools option feature manager. When you're dragging a part of the assembly from one over another, you may again see the cursor assemble figure 13. If you do not want this to happen, press and hold the Alt and the key while dragging this part. The cursor will change with the reorder with the cursor. A reverse L-shaped arrow. The part will be placed in sub-assembly rather than within it. Inserting a new assembly. Along with the right mouse menu option from the new assembly here, which takes existing parts and puts them in a newly created sub-assembly, you can use another option called Insert New Sub-Assembly. The name of this function doesn't adequately describe the different functions of the new assembly. Insert the blank sub-assembly at the point of the design tree that indicated by the right click with the play for the components of the sub-assembly, dragging them, dropping them from the main assembly. You can open the assembly in its own window, inserting parts by using the usual method of drag and drop and insert the component tool. Dissolving sub-assemblies. If you want to get rid of the sub-assembly part, keep the parts, you can either dissolve the sub-assembly option on the right mouse button. The option, some of the other same consequences from the new assembly here, with the option that makes that moved in sub-assembly to the upper level of the assembly. You move the levels context relation with the assembly feature. Organizing for performance in SolidWorks. Performance refers to speed. Sub-assembly contributes to speed saving. Modeling techniques, segmenting of the work of the software needs to do at any one time. Solving mates. The mates contribute to putting the pieces of the assembly together, solve at the top of the assembly level under normal circumstances. Some of the assembly treatment the same as selection when the part of the welded together. Their mates are not solved at the same time on the top level. The assembly's mates are solved. They segmentating the mates leads to improve performance by solving only one set of mates at a time. The mates are usually solved with a single group of the unless they are as special situations of the mates of the in-context feature of the component of the pattern, instant of the assembly feature for the all, which have already been described in this chapter. In one of the situation curve, the mates must be divided in separate groups that solve with multiple times. This is done behind the scenes for the user, that does not have to worry about multiple rebuilds that affect the user only in terms of rebuild times. Show the assembly with a start of the other part flex part off the assembly part with a little assembly to the blue button to box to the right, using flexible sub-assemblies. When you put sub-assembly upper level assembly, the mates of the part of the sub-assembly are not solved with the upper level assembly. The dispute of the sub-assembly with the mechanism does not allow the dynamic assembly motion of the upper level assembly is considered rigid. For example, 1316 with the front fork lower as linkage for the mechanism, but also sub-assembly without reassembling with the parts of the fork. Upper level assembly you can allow the mates of the fork sub-assembly to be solved in upper level assembly solved as option component properties of the dialog box shown in figure 1316. When selecting flexible option, enable the mates of the sub-assembly to be solved with the upper level assembly, which allow the part of the sub-assembly to move to the upper level assembly access to the component properties of the dialog box. Right click with the sub-assembly, select with the component properties from the menu. Alright, now we're creating a flexible sum of the assembly with the component properties, the component name, the incident ID, full name, component reference, pool reference, component description, model document path, display state, high components reference, displayed state, and change the display type, configuration, specific difference, specified reference property, suppression state, resolved, rigid, and flexibility, envelope, exclude from made materials. So we've now looked at creating a flexibility assembly and the component properties. Flexible assembly have become more reliable, easier to use. You should work within them and do some experimentation to see if they assist the model processing. If you find they cause trouble in some situations, they're easy enough to deactivate. Organize the bill of materials. Bill of materials is a table placed in either end of the drawing of the assembly or any of the actual assembly. The table show the part of the assembly. They include the other information, some of the parts, the quantity, the description, and the custom property data. Business and other representative of the assembly with the assembly various ways by using the manufacturer resource planning with the enterprise resource planning software. Methods for the accounting manufacture of the organized assembly is not always the same. Are those of the engineer or the designer might choose, but some come. These require bill of material on the drawing to match the manufacturing resource planning and enterprise resource planning bill of materials. Best practices. When you're forced to model something in a natural way to satisfy the outside of the demand, such as the special bill of material requirements, it might be attached with the unnatural part of the model normally, and with the situation mentioned here with the manufacturing resource planning. Force of assembly put together the requirement of bill of materials management resource planning. You should report and separate bill of material of the assembly structure rather than build an assembly that makes the Solidworks function difficulty of the ensure of the bill of material becomes manually maintained document. Alternatives to that approach would be make the configurations of the entire new assembly documentation drive of the bill of materials. Grouping sub-assemblies relative motion. More natural way the group sub-assembly conserve the relative motion. If the bicycle, for example, each of the wheels separate sub-assembly becomes the move of the unit relative to the rest of the assembly. The give group of the sub-assembly relative to the motion greater than some of the modeling, but it does usually reflect the producting reliability of very well. Use the method often up to the parts over the sub-assembly disassemble in order to actually put the parts together. However, if you have the consideration easy modeling, that you should probably use the method. Organizing group of the purchase of the components. If you're modeling a product with the grade of the shopping label of the purchase component, but the method make the most sense of the organizing sub-assembly, the group of the parts of the purchase together, and the fact that the purchase sub-assembly are often model single parts except when relative the motion is required of the purchase assembly. For example, the bike assembly with the sprocket on the rear of the wheel with the purchase has separate unit of the parts of the mount with the wheel move, the relative to the sprocket that are driven by the chain. With the example of the purchase part would be mounted with the sub-assembly, show relative motion bike chain with another purchase with the sub-assembly not yet but then add the assembly with a more complex model. So that show the individual links and the review of the path of the override both the complexity of assembling it and the performance configuration exercising all mates. Although the bill of material method of organizing assembly sometimes lead with the unnatural solutions, you should not discard it altogether. You can devise concessions in order to make the bill of materials work automatically, then you should do this. Depicting an assembly process. Manufacturing assembly process need to be the document as well with the individual part design. You often need to create exploded view, assembly, instruction, manufacturing, service documentation. Each step, multi-step assembly process. Figure 1317 show the example over the type of the process documentation. 1317 show the assembly process documentation, and then it's right over here on the left. This task is certainly different with the nature of the design model with the assembly. If the required with the entire separate with the assembly of the model, give it the perform with a different step of the separate configuration with each of the process step. Examine the view of each of the configuration, influencing with the item number, the balance, the number of the part, according with the item, the number of the bill of material of the course. You do not know the item number until the bill of materials created. The influence of the item of the numbers for the reorder of the parts of the assembly will be discussed later in the chapter by meaning will the adding the numbers and manually numbering the balloons. Separating steps, each of the steps corresponding assembly configuration discussed in Chapter 19, controlling assembly configuration display save, then you can place them in a separate sheet. Drawing discussed in Chapter 30 with the creating assembly drawings. Each of the configuration can have the multiple exploded view if necessary to show all of the steps. Perform pattern consideration most efficient way. The pattern large numbers of the component of the assembly, two of the pattern, single sub-assembly with all the components to be patterned, although they may not be easily combined with some of the other consideration mentioned previously, and another option that you can use to organize assemblies. Using folders. Folders are permanently either the assembly feature menu for the group and part of the mates into the special classification for each of the browsing groups. They can easily hide or show the suppressed for the unsuppressed as appropriate to figure 1318 show some of the examples of these folders. Alright, the folders for the organized components and mates. We've gone to the mates, and now you see the motion mates, the ground mates, folders. Creating folders in Feature Manager, you can add the folders in Feature Manager in two ways: by adding existing component to the new folder, or creating an empty new folder. You can add a new folder. You can add a new folder, right-click with the component with the mate selection of the components or mates, and select with the add new folder from the menu with the move the component with the main into the move the components or mates into the folder. Folder do not affect the assembly in any function way. They are simply organization, speed, browsing, selection. Use creating a new folder simply. Create a new folder without putting anything into the right away. Right-click either for the mates for the components listed with the select with the create folder from the menu. Reordering items in the tree. Sometimes you want to reorder the items in the assembly tree. For example, if you want to place the items into one of another in the tree, with maybe preparing to put the items that are next to one another into a single folder. You may also want to reorganize the components of the bill of material display. You can reorder the mates with assembly by dragging them. Mates display in the order which they are created, but the order of them is not significant. You can reorder them however you like, with the components are displayed in the order with which they are added to the assembly. You can reorder them in any way you like. Best practice is often useful to have the ordering strategy help you do the work with a model. For example, this should try with the biggest part of the parts. Everything else will be made with the part that is traded as a ground. The first part in the sum of those then put the fastener of the other cosmetic bill of materials. Drive the part at the end of the tree, usually with a descriptive name folder. Working with the tree display option. Display option for the feature manager for the overlook by can be useful with the display with the data parts, sub-assembly, mates, and features. Figure 13 show the right mouse button option to the right. Must right click with the top level assembly name of the feature manager. Click on the right tree display to access the menu. Note all these options are available. The parts drawn with it as well, with the example of the view feature for the option view mates and the dependency of the option that's related to the assembly. Showing feature for the name and the description of the if so through the having added description for the feature for the doing the figure 13 show the option displaying feature name description in feature manager. Generally feature names are sufficient. The description can be added with the search for the filtering egg options in long trees. Feature trees. Showing component with the configuration name the descriptions. By default, Solidworks use the file name of the part of some of the component name. If you want to use some of the name of some of the feature, you must change with a couple of settings. First, go to the Tools option, External Reference, turn off the update of the component name when the documents are replaced with it. Enables you to keep some of the component with the name, even if you replace with the component. You have the replace with the component functionality, opposed to simply deleting and restarting it in order for this to work. Second, right-click with the component with the name that you change. The component property shown. Figure 1319. You can change the component name. If you do not have the first step, your lengthy warning message note of the difference between component name when I change manually with the model document path, which the affiliate filled in automatically. Dialog even has a handy hint on how to replace the component if you want to file replace. Figure 13.9 shows change the component and the component properties. Component properties, you can change the component name. Double stop reading with this is double stop reading now. Don't stop reading now. This gets slightly more complex. If you want to rename the component with the assemble the feature name of the component, pop the dialog box with the opportunity. Try to slow the double click with the F2 window method, but this wouldn't work unless you have select the go to tools option feature manager to turn on the setting. Allow component file to be renamed from the feature manager tree. Then when you try to rename all of the feature manager, to go to another Solidworks warning shown in figure 1320. At least two of these. At least here you can choose the do not show again option. Renaming the feature manager gives you a warning of the renamed documents. You can temporarily rename the document or cancel or do not show again. Using component reference of the instance for the component part property for the dialog box enables you to enter the component reference information capacity. Typically, use the electrical diagram for the similar component different values such as the power rating capacity of the resistance instance of the same of the component with the Solidworks assembly with the same of the component references can be listed together with the bill of materials. And for the different component reference of the listed separately on the bill of materials. Figure 13.2 show the parts listed on the part with the component reference listed for each of the instances. Our figure 1320 shows the listing parts assembly containing the component reference information. In order for component reference to be usable in the assembly drawing with the drawing, you must have the bill of materials. The component reference column bill of materials are handled with the detail of the chapter 31 bill modeling multi-bodies, where the topic component reference will be revisited, viewing and feature of the mates and the dependencies. Set option figure 13.3 determines whether you see the parts of the feature of the assembly made for the name of the each of the component of the assembly tree. The default setting of the part of the feature sub-assembly components to the display, just to have the parts of the sub-assembly were opened with an open window. The view mate of the dependency option can show with the feature of they are placed in a separate folder. Option makes it easier for some of these mates to sign with the individual component. For example, the figure 13.22 with the image of the right show with the main directly with the bike from viable bike frame pipe part. This often makes troubleshooting much easier because of the isolated with the made single part note of the first folder, the owner of the part name, the image of the left, and figure 1320 of the maze folder indicates regardless whether you choose the display maze features as you have easy access to the other type. Figure 1320 with the view feature for the well is made a dependency. So we looked at the bike frame and view features and the mates. The view mate tool extremely valuable looking at how assemblies held together with the maze with the right click of the component with the assembly tree of the view maze from the right mouse button in Solidworks. Highlight with the component with the click of the maze. All parts of the maze of the component transparent. All of the parts not related that are hidden. Solidworks also display the small die box list of the maze touching the component you clicked. Figure 1323 show the arrangement of Bible bike assembly. This is big help when they make visualization. Control select the multiple components before starting with the view maze tool. The Solidworks no longer display with the common maze of the bold format. It just lists at the top of the dialog box. Alright, 13 show the maze of the property manager plane. This is the property manager. You now see the mates in the list. The tutorial arranging assemblies. Within this tutorial, you will take an assembly already put together, the group it in components, sub assembly convert one, sub assembly flexibility, sub assembly notice of the assembly command with the right mouse button. You've selected may be shown with authenticated with the right mouse button menus. To remember to give this, double click with the button on the right mouse button menu, or choose the tools customized option of the menu. Click to show all buttons with the both shortcuts and menu customization. Follow the steps to learn how to efficiently arrange items in the assembly start option with the starting open by robot assembly solid AS assembly file. Solidworks assembly file from download material for the chapter. Note the file name long with someone that difficult to read. This would also apply with the file sequence numbers of the file name instead of the descriptive name. 2. Display with a more readable name. Right click with the name assembly top of the feature menu of the tree. Display with the menu of the turn and show with the component description. Repeat this step. This time turn off the show component names. Using figure 1324 show the display with the feature manager after change to even top of the little assembly for the description rather than the file name. Figure 1324 simplify the feature menu to display but include the description. Note that the two components of the easier clumsy file names rather than easy to read. A description to cover the description never been entered for the two components. One of the large cylinder piston with the part with the clicking with the part of the feature manager, then clicking to open the icon with the tube of the file with the properties menu to make sure that the custom tab is active. Create new property with the description assigned with the type of the text for the entire large cylinder piston. Throw the value with the save of the part of the control S for the fastest way to do that. And flipping back for the assembly, the fastest way to do that is press and hold the control key. Press tab and this displays that has not yet been updated control Q for the force the retreat and rebuild. Open a large cylinder body part. This part with the file saved as the menu saw saved as when prompted. Leave the menu, leave the name as is, but where its description into the large cylinder body is shown. Figure 1325. Click yes when asked when you want to replace the document with the same name. Flip back for the assembly when you are finished. You may have the rebuild set. See the change update. Press and hold control. Select with the large cylinder piston, large cylinder body parts from the feature manager. Then click on and select the form new assembly from the menu. If the assembly template with the description will appear with the feature manager. If the file name will not appear. If not, the file name will appear. You have created the assembly virtual component with the parts external of the document, actual file with the corresponding to the entry. Entire entry into the assembly feature manager of the switch the tree display show with the file names. You will see that shown figure 1326 with the name of the assembly of the assembly 1 robot assembly. So the virtual component gets the default name of assembly 1 filed by the name of the parent assembly root assembly to ensure that they are unique name if there are other virtual components of the other assembly. Figure 1325 adding the description save as dialog box. So underneath the save as you can write the description. 1326 shows the newly created virtual components of the assembly external parts. Press and hold Control key, base mode of the main arm motor with the cradle with the make sure that another new assembly created the sub-assembly with the right click with the shape of the assembly with the external file from the menu set and select with the save only of the assembly to an external file with the shape of the name of the assembly to with the cradle, save it in the same path with the rest of the parent's virtual component with the save externally with the you can create with the undo the command, reverse it with the right click with the external feature with the feature menu with the select with the make the virtual from the menu. In figure 1327 the notes the several of the mates with the comment came along with the new assembly with the these are the mates between the motors from the cradle of the mates located with the cradle to the other parts. In the assembly, they have remained in the upper level assembly. Figure 13.27, the cradle assembly brings along internal mates. So now we're looking at the mates of the cradle. Notice you cannot undo the sub-assembly operation if you do not remove the assembly. With the key of the parts, right click with the assembly to select dissolve sub-assembly from the menu. If you try to move the parts of the assembly, you know that all the parts work as they should, except for the main arm does not move up and down. This is because you've determined the cylinder and piston sub-assembly are not solvable on the top level of the main, which means sub-assembly cannot move within itself. To get around with this, you need to make the sub-assembly flexible sub-assembly, which solve the sub-assembly made for the top level assembly. Right-click cylinder sub-assembly feature menu with the select with the component properties menu with the lower right corner of the dialog box with the option of the solve the bridge with the flexible. Change the setting to flexible. After you click OK, return the assembly. The main arm will move as it did originally, with the piston will move it in and out of the cylinder. Note that the symbol for the assembly chain with the flexible assembly. Tutorial managing the feature manager. The tool view of the Bible Bike Assembly solid assemblies file located in Chapter 13 folder with the download material of the Widely website. Open the file with the file. The step to learn about the managing feature manager. Create the new assembly with the existing assembly of the parts of the Bible Bike frame and the chain say Bible Bike. Name the new assembly frame assembly Solidworks assembly. Reorder the new frame assembly top of the design tree. Reorder the other parts of assembly. Bigger assembly appear with the first on the list with the part appear on the bottom. Remember, alt dragging of the component prevents it from being placed into the sub-assembly. Drag from the bottom bracket into the frame and assembly drag for the using alt key for the assembly feature for this point in figure 1328. Starting state as of step 4. Select both wheels and then add to the new folder the right mouse button menu, the name of the new folder wheels, move it to the bottom of the tree, expand with the mates of the folder, select with the first 4 mates, put them in the new folder, select with the add to the new folder the right mouse menu button, name the new folder, consenter made with the remembering if you make the mistake that you go file with the reload the assembly part of the last saved state. Bottom line, assemblies are more simple part of the sub-assemblies put together the mate relation with the other type of the feature for the placeholder that can also exhibit the assembly feature manager. Organizing assembly components fairly straightforward. Can offer the benefits of finding in the parts as well with the controlling suppression from the display state with the globally. The assembly feature manager the control assembly option from the data the display with the sub-assembly part. Sub-assembly parts configuration metadata features. Remember that all the data with the include the Solidworks documents can be accessed, reused later, so that it's worth the effort of the name and the property description can be very important both at the part level but also with the feature for the figure. Master it. Use Solidworks Treehouse to establish framework with a symbol the product with the 2-layer with the sub-assembly. Add some of the custom property documents that you have might want to with the bill of materials. Use the property template. Save the documents to the special folder. Master it. Speed is a huge part of the building. The efficient assembly measure the speed with the tools. Evaluate performance evaluation tool. Open the performance evaluation tool. Looking at the assembly, for example, the bike finish with the solid assembly. They will learn what you can do about what types of features, techniques, cost the most must rebuild with the display regeneration time. Master uses assembly visualization tool. Sort of parts according to the various criteria. Becomes more familiar with the information presented by performance evaluation. Alright, Chapter 4, Getting More for your mates. More from your mates.